The first one is about pre-design considerations. The very first one, the first thing you have to understand that not all bioinfiltration systems are designed same way. For that design, there is a lot of variability about size and different components. And if you know why those are there, you will know how to change those design. So these are the 5 factors that you have to remember. First one is the scale. Scale means how big the bioinfiltration should be. And those scale depends on how much stormwater is designed to treat. And those amount of stormwater, the runoff volume, let's say the Q runoff, more than Q runoff or volume of runoff that you wanted to treat is a function of a lot of factors. The number one, you know that it's a function of the area, catchment area, and also it's a function of the runoff coefficients, how much trees those are, coefficients. And then also it depends on other factors like what type of slopes and all that factors, because that will determine how quickly the stormwater is entering the space. So this determines the scale, means the size of the treatment unit. The next one, it also depends on the site characteristic, which I mentioned before. When I say site characteristic, it's also C, runoff coefficients. Runoff coefficients that determine that's a function of a lot of factors, soil types, and then you know that how much infiltration it can have, how much green space it has, all that factors. And then also it depends on climate. For instance, if you have area which receive lots of stormwater or lots of rainfall versus something dry area, those design will be very different. So you got to know, think of climate as well as soil type. Then the third one is a drainage or conveyance, which means how quickly you want the water to be drained and where you are going to drain into. Is this going into groundwater, or is this going into storm drainage? So here this is all about outlet. Is this going to groundwater? That's the first option. Natural infiltration, that depends on the soil type, and the second one is more about whether it's a storm drainage, which is mostly related to water harvesting. And then you have to think of if you don't want for the treated water to get into groundwater because it is shallow and the groundwater is used for drinking, then you might have to think of a liner. So that liner will prevent interaction of groundwater. So that's the second other aspect of drainage. The fourth one is a treatment target, and that's essentially about your TMDL. So if you got to design such a way that you remove the pollutants of interest. So if this is not, let's say you wanted to design to remove heavy metals, you have to think of what kind of amendments you wanted to use. So this is mostly on amendment type. Also sometimes, like let's say nitrate, then you have to have a submerged layer for that. The fifth one is about water reuse. So what's the whole intention of installing this infiltration system? Is this something that you wanted to do for water use or reusing that treated water, or is it something just getting rid of stormwater so that you have volume reductions? Or you may have some other ecological functions like how much plants you wanted to have, green space you want to have because of other ecosystem functions. For instance, if you want the birds and some kind of the animals and other things to return to the space, which is normally they are repelled by lack of any green space or plants or natural habitats. That's why you wanted to put those. So these are the different things that you have to think for pre-design considerations. Once you identify this is my goal, then you can start thinking of other factors. So the next option is what's the scale. Now, as I said, the very first thing that we discuss about is the scale, how big the size should be. Again, you got to think of climate as well as the catchment area. At the same time, you also have to think of what's the end product of the biofiltration system. The very first one is design storm. That's about climate. So every area there is a rule or there is a criteria that you have to treat certain percentage of the storm events. For instance, in LA, the storm event will be 85 percentile storm. Okay. So if you have that means 24 hours, 85 percentile storm. So you know that what's that number is for different locations, and then that's the rainfall intensity that you have to capture all the stormwater you have to treat for that kind of rainfall. And so that can vary from location to location. So you have to know what kind of design storm would be for your cases. The next one is catchment area. If you it's a simple thing, you know. If you're Q equal to CIA, and that I goes here, rainfall intensity, and this area is the catchment. Okay, so that's the catchment area. So that will determine how much flow of water will get into these systems, these locations, and that's your treatment volumes. Not all of them you'll treat, but at least you'll treat for the 85 percentile storm event for Los Angeles. So you got to think of how big your catchment area. If your catchment is pretty big, then you have to have also a large scale treatment system. So that means if your area will, the scale of your treatment system will increase if your area of catchment or catchment area is increasing. Okay. So scale increases if area increases. So here scale also increases if I increases or rainfall intensity increases. The third one is about performance objective. Now again, performance objective is this designed to remove pollutants or not? Is this designed to remove as quickly a lot of stormwater or not? No. So based on that, let's say you have goal is to remove contaminants. So that means if for removal of contaminants, you need to add more amendments. Or the controls that help removing pollutants. So that means you can increase the size. Your size should be increases. More importantly, the depth should also increases because pollutant removal depends on the hydraulic retention time, and hydraulic retention time depends on how long it stays in the system. So longer the water stays, that means you will remove a lot more pollutants. The next thing is about site properties. That determines whether you have stormwater moving into the ground quickly or not. So the very first thing you will think of is what kind of soil it has, because that will determine how much amendments you need to add. So the first thing is, let's say KD, or amount of or adsorption of pollutants. So that depends on whether you have lots of organic carbons or not. Fraction of organic carbon. So if it's not there, then you add more. So that's one component. Then the second is hydraulic conductivity. So that's hydraulic conductivity. So that's about how quickly water can infiltrate into ground. So that depends on particle size. So if you have a clay soil, then you have to add lots of sand in it. So that means you will increase particle size if you want to remove pollutants. Then the last thing is about, not the last thing, the second thing is about site properties related to how far the groundwater is from the biofiltration system. Because if it is a shallow groundwater, that means there is an increased risk of contaminations. So if that's the case, then you got to have a liner because you don't want the groundwater to be polluted. So most of the cases, if groundwater is very close to the surface, then you should not have an infiltration system there because you will ended up contaminating groundwater. So here you are going to make decision about shallow groundwater versus deep. If it is deep, then you most likely can install there. If it is shallow, you have to have extra designs such as a liner. Uh, so if you put a liner at the bottom, then most likely it will, let's say there are plants, if you put liner and then you have a system, that means you are protecting no groundwater contaminations. So that's the second step. And the third one is land use, because you determine what type of pollutants you are going to get. If you have so this is related to source of pollutants. For instance, if you have a polluted area like a gas station nearby, you should not have an infiltration system nearby, because it means there is accident of lots of pollutants coming in and more increased chance of um, contaminations. So if there is a highly polluted source nearby, you got to have that design like liner or any other factors before you can have this kind of system. The next one is about drainage. Again, this is because these are infiltration system, your goal is to get rid of water as quickly as possible. So there's a spelling mistake here. Um, there are different kind of infiltration system design. It could be infiltration basin or it could be bioswale. The difference is very different. It's about how the stormwater is drained. Bioswale may not have a lot of infiltrations. This is just a storage with limited infiltrations, whereas infiltration basin is expected to increase infiltrations. It's more infiltration than the bioswale. So you can think of that, Um, and so in fact, actually the depends on there. Here it's all about whether there is how much overflow it can have. Okay. Um, so this is something you have to think of. And the third one, or the second point here, is underground drainage. This is about if your soil doesn't have lots of high infiltration capacity, natural soil, you do have to have a pipe or some kind of collection system, collection net system to capture, to uh, to um, to drain treated stormwater. Okay. So this is again infrastructure design that will add to cost, but you got to think of that, and that's all depends on the soil type. If you don't have a high infiltration capacity soil, which is case most of the time, you got to have a pipe there. Then the third one is about connectivity to other waterways. For instance, if you have a lake nearby, you don't want to short circuit the polluted water. Then you have to think of all that. So how near your system is to a groundwater or a source for drinking water. Okay. So mostly what you're going to think is um, the connectivity means it's a storm drain to a water body that is used for drinking. Okay. So if it is too far away, then it's not much risk. That means you can install there. If it's too nearby, you have to have some kind of measure to prevent that kind of accidental contaminations. The last one is a treatment target. As I said, this is all about TMDL or contaminants type. So based on land use, you should be able to find that what kind of pollutants are expected. For instance, if you have industrial area, then you can think that there will be more heavy metals as well as any kind of solvent. But if you have, let's say, domestic or residential area, um, then you can think of there will be pathogens and the nutrients will be more likely the factors. Okay. Then you have to think of TMDL. That's based on what's the intended use of the water that or water bodies that receive that stormwater. And there are many other types of pollutants as explained here. So you got to account for those factors. Then final one is ecological functions or what's the intended use. For instance, if you have use for drinking water, then you got to have more strict regulations about what pollutants has to be removed. And second, if you have a location which has lots of pathogens and you have to use it, pathogens, the limit is 1 in 100 ml. So that means you've got to have removal or some kind of disinfections after use. So these are all the other factors that you have to think of, whether you are going to store the stormwater and treat them for kind of infection and disinfection before you use or not. All those conditions apply based on intended reuse of stormwater. There is other function, as I said, there are ecological benefit for a stormwater treatment system like biofiltrations, where you'll have plants, you'll have green space, you'll have also large location, which is more like a natural habitat for lots of animals. So having those kind of systems there will increase that factors. In fact, sometimes some are also not good. For instance, you don't want bog, you don't want mosquitoes in your backyard. So that means you have to think of all that other factor. What kind of design you should have so that it doesn't have negative ecological consequence, such as mosquito. And mostly it's related to whether stormwater is being there, whether it's not ponded well or not. Because if not ponded for more than 48 hours, or if it is not, all the ponded water is not removed or infiltrated into ground within 48 hours, you might expect that there will be mosquitoes. So these are all consideration you have to think, and then at the end you'll see whether these are all related to any other design factors.